Welcome to the HiRSE-Seminar series on research software engineering in Helmholtz and beyond.
Welcome.
Yes, thank you very much, Claire. Thank you for this lovely introduction. I'm going to share my slides and say how much I'm glad I can be here and do this presentation, especially on metadata, because metadata is actually my soft spot. I came into the software heritage team 9 years ago to solve a big problem, which was building the free and open source semantic web. So this was one of my challenges. And today I've prepared some slides to help you and guide you with your metadata questions. Before I start in diving into this subject, which is metadata for research software engineers and metadata for research software in general, a question that I always ask myself is, what is actually software? So I'm a software engineer in my training. And when I first came into the software heritage team, that was the question: what do we want to describe? What is the software? And this is a way that I found myself reflecting on software as a concept where we think about the project or the entity that might be described in a catalog. There's a community around it and an idea that is not a digital artifact. And with that, there might be a very, very large collection of digital artifacts, software artifacts, including executables and source code. And when we think about the source code, actually the source code is the most important part, because this is where the knowledge is actually represented. And so this source code is the invisible backbone of all digital infrastructure. Preserving it is very crucial. And for those of you who do not know software heritage is actually the universal source code archive trying to solve the problem of not having unified place where all code can reside. So for this presentation, first I will guide you through this introduction with what's at stake. After that, building the software pillar of open science using software heritage as a core infrastructure. A deep dive for better metadata using the research software metadata guidelines. So I will talk more about that. And finally, supporting research with new players in academia. So I hope I have time to go through all of these comfortably. Feel free to ask questions during the presentation in the chat. I'm not sure I will have the possibility to kind of respond directly, but then we can take that after in the Q&A part at the end, which will not be recorded. What is at stake? So there are 4 elements that are very important when we want to have software visible and recognized. We want to do this culture shift where research software is not just a tool, but a clear research output. For that, we need to archive the code so it can be accessed and retrieved. We want to reference it to make sure we can identify the specific software artifact. We want it to be cited for recognition. And the final item here, which is the actual topic of this webinar, is description. We want to describe to make it easy to discover, to have it visible and understandable. And the Universal Source Code Archive, so Software Heritage, is working tirelessly since 2015 to collect, preserve, and share all publicly available software source code, because preserving our heritage is enabling better software and better science for all. It was created by 2 researchers, Roberto Di Cosmo and Stefano Zacchiroli. And now we are a big team, more than 20 team members. And as you can see, it's also a big archive with more than 429 million projects and more than 28 billion source code files. One thing that we say about software heritage, it is the Library of Alexandria of source code, launched by INRIA, which is a research center here in France. So something that I haven't said, it is I'm based in Paris, and most of the software heritage team is here in France. It is backed by many sponsors, so it can be relevant for more than just academia. It's relevant for industry, public administration, and for cultural heritage. And we work in collaboration with UNESCO, celebrating every year software heritage and software archival at the UNESCO headquarters here in Paris. And what brings me here is, as I said at the beginning, is this metadata topic. I said that I came to the team to build this semantic web of FOSS. And part of this mission was to analyze the metadata landscape. And then I discovered CodeMeta. I'll talk about a little bit about that, about choosing one vocabulary without creating a new one, developing components to ingest metadata and index metadata, and communicate with the larger community. And this is how I became aware of many efforts for citation, for software recognition, by communicating and raising awareness about the importance of metadata for software. And we need to identify the users of the metadata so that we can provide better metadata. And better metadata is quite important. I hope that, so sometimes most research software engineers and researchers say, yes, metadata is important, but then we need to do the metadata, and this part is much more difficult. So who is responsible for the metadata? This is a kind of a strange loop. Is it the infrastructure? Is it the institutions? Is it the researchers? Who take care of this metadata? And the metadata is a tool for recognition, for visibility, for findability, understanding, reuse, and re-execution. And without the metadata, we lose the key to decipher the knowledge. As we said, the knowledge is in the source code. We can have also metadata in the source code. And we need the metadata to understand what is important. Next, we want to build the software pillar of open science. So what we mean about that? Software, research software, is something special. During the work around the Fair for Research Software principles, we discussed a lot about what is research software. We agreed on in collaboration on a description or a definition separating research software from software in research, where research software is created during the research process or for a research purpose, while software in research is all the software artifacts that are used to do research, but are not necessarily created in the research process. And software can have multiple facets. It can be a tool, it can be the outcome, so this is the research software, or it can be the object of research, where research is done analyzing the code itself. We want to build this pillar of software to make it more recognized alongside publication and data. In academia, software is not created in isolation. Research software is not created in isolation. It is part of a very fragile software stack, where the research software is actually the high level here of the project-specific code or domain-specific tools, which can be archived in a scholarly infrastructure, but it is dependent on many other parts of this stack. And one thing that we need to be aware of, that this stack is fragile and can collapse. So this is actually a diagram by Konrad Hinsen about dealing with software collapse. And this is important when we come to the question of reproducibility. How can we make sure that reproducibility can happen? This is by taking care of the full stack and recognizing that software is just one part. The research software is just one on top layer. In open science, we discussed a lot about FAIR and the FAIR principles. I imagine that most of you know FAIR for research software, and have already difficulties in applying FAIR. And what I will say now might depress you, because I do think that FAIR is not enough for software, even though FAIR is on a good journey towards reproducibility. It is really not the key element that can help software be more recognized and more usable. Because FAIR, as you can see in this diagram, is actually here in the middle. It is when we have a PID, we have some metadata, some documentation, a license, very important, the license, but then access to an executable that might work, might not work. We might not have the full stack to make it work. We don't have access to the source code if it's FAIR. We need more. We need it archived. We need it open. This is towards a more open science stream. So open science isn't complete without open source. Now, is CodeMeta enough for software? Well, CodeMeta is only just one part of it. And as we will discuss here a bit of guidelines and recommendations for research software engineers to improve the metadata. CodeMeta can come to the rescue and make the software more fair. And yet, fair is not enough for open science. CodeMeta can be used as intrinsic file. I will share a slide about that a bit later. And it is used today in a workflow with different scholarly infrastructure. Whether a researcher is working in a forge, well, you must know how that works, where collaborating with peers or in large communities on GitHub in this forge, having the file in the code repository, saving the code, and then having that notified in an infrastructure like Zenodo, like HAL, make it as a two-step process for better visibility. And this is where I go discuss more the metadata aspect and how we can use the research software metadata guidelines. Metadata is very scattered. What you see here is the word cloud using the CodeMeta crosswalk table. I haven't yet said what is CodeMeta, even though in the beginning Claire introduced me as contributing to CodeMeta. Well, CodeMeta is actually a very important effort to consolidate the metadata landscape. It is a new vocabulary that is a subset of the schema.org software source code class and software application class. So it's not a completely new vocabulary, but there are a few new terms that were invented in CodeMeta for specific academic use cases. Something very nice in CodeMeta is the crosswalk table, where different vocabulary are mapped so that we understand each language with their own metadata terms. And in this cloud, you see the terms that have the largest visibility are the ones that are mostly used in many vocabularies. So the smaller terms are the ones that are very have minimal usage. And while name and license and description are massively present, because in many vocabularies that try to describe software, they are present. Where is this metadata available? Well, there are two different places, kind of large meta places, where metadata can be found. It can be found as extrinsic metadata on a scholarly repository, in a catalog or registry. On development platforms, you can add metadata to your code repository, but it's not in the source code files. Also, package managers have metadata. Scholarly publishers that have records of software can have metadata. And finally, there is some information that comes from citation and mentions in research articles that can link articles to software. Those items are extrinsic to the code. With that, we have metadata also in the source code files. We have a README file, which is considered a metadata file because this can be used as the description of the software. Hopefully, we have a license file, but we see that that's a file that many of you don't use. I hope that you have enough instructions how to do that. This is very important, especially if your code is publicly available. Sometimes there's an authors file identifying clearly the authors, and we can find a CodeMeta.json file or a CFF, citation file format file, in the code itself. The advantage of having the metadata in the code, and this is my personal recommendation, is that it's saved with the actual source code. So wherever it goes, if it's in an archive, if it's reused, the metadata is kept with the code. So this is something that not many are aware of, that these files are used in infrastructure for indexation and search mechanisms. These intrinsic metadata files, as I said, are very important. The README is a human readable file. Maybe in the future, maybe already now, it can be scrapped and be very machine actionable. But if you want to be precise, a machine actionable file like a CodeMeta.json file or a citation CFF, those are machine actionable files that can be very precise in the way we describe the software. I've described CodeMeta, but a little bit more about CodeMeta is the 10 years in the making. This effort, this initiative started in 2015 by a 411 software citation working group. Since then, there was a lot of community effort around it. If you are yourself interested in metadata and influencing this community, you are welcome to join in the CodeMeta repository on GitHub, putting issues, commenting issues or discussions. There's a lot of interesting discussions there now also around metadata for AI usage in code. So these are very interesting things that are happening. It is created and maintained by the community. We have a governance model with a project management committee. The updates of this CodeMeta community comes into the CyCodes Consortium, which is a consortium of scientific software registries and repositories. And the reason is that a lot of different infrastructure are aligned with CodeMeta. So one option would have been to have a crosswalk between the properties used in the infrastructure and CodeMeta, and another is directly exporting CodeMeta from the infrastructure, which many are doing today. So you have a few dates about the recognition of CodeMeta, about the launch of the different efforts, about some dates about recommending CodeMeta, and finally our first CodeMeta party that happened last year. And we hope that this CodeMeta party will be something that we celebrate every year to improve CodeMeta and emphasize the need of better metadata for research software. We have also different tools for creating CodeMeta files. So you have the CodeMeta generator, which is an open source tool, also in the CodeMeta community, where you can contribute or go and use the tool to have your own CodeMeta file. There is now also a nicely auto CodeMeta generator using just a repository URL. It will fetch metadata from the repository and create a file, a CodeMeta.json file. This was contributed by the UPM, the ontology engineering group. These efforts around CodeMeta are important for cross-infrastructure coordination. It started with a clear policy decision to make this work with the usage of a standardized vocabulary. So in the HiRSE report, which is called Scholarly Infrastructure for Research Software, that was published in 2020 by the European Commission, it's a report recommending on the interconnection and interoperability between infrastructure, leveraging this metadata standard. And one of the key elements of this report is the also connection and integration with Software Heritage, the Universal Software Source Code Archive. And what we are doing today is connecting those different infrastructure to Software Heritage using the CodeMeta vocabulary. Another thing that happened in this recommendation is the recognition of the software hash identifier, the SWHID. And recently, just last year, it has been standardized as an INZO standard. Software Heritage is acting with that as a metadata broker. We are leveraging the metadata from CodeMeta and translating in Software Heritage from the different sources the metadata in one place. We ingest metadata, we extract metadata, and we try to deliver consolidated views to different stakeholders. So this is something that we are working on. All of that for one important culture shift, making software a first-class research output. And I think that everybody here agrees that this is not yet a reality. And we are working toward that. We are using CodeMeta, so CodeMeta not just as the vocabulary, but as in every part of this pyramid. This is the Nosek pyramid. I imagine that many of you know it, trying to do this through metadata, because CodeMeta is not just a few added properties to schema.org. It's actually making sure that this research software is visible, is citable. It can we can have indicators and incentives for researchers to make the research software that they are creating more important in this in academia. All of that was a build-up to this point, which is the research software metadata guidelines. This output was delivered by one of the EOS projects that has already ended, Fair Impact, proposing 7 aspects that are on one side aligned with the Fair for Research software principle, and on the other side aligned with the HiRSE report stakes. And these 7 aspects are very detailed, so there's a lot to capture here. It can be overwhelming, but I will go through each one of these aspects in the next few slides, so you can have a real understanding of what can be added in terms of metadata and how we can improve the quality of the metadata. Also, so these are the aspects of the research software metadata guidelines. There is also a checklist that can guide each person that wants to improve metadata with very direct questions. And this is actually how I will present this here, each aspect with the checklist part of the recommendations. In the guidelines, we have high-level objective, which is a high-level idea of why this aspect was imagined, and then specific recommendation with a specific identifier for each recommendation. So this is how it's kind of a how to read the research software metadata guidelines. If you have never read the research software metadata guidelines, I do encourage you to check it out, especially if you're interested to improve your metadata. So first, general metadata requirements. So the objective, and I'm not going to read each one of the checklist points. You can have kind of a high level overview, and you will have access to the slides later, so you can read it directly from the slides. For the general metadata requirements, we want to ensure the collection, curation, and maintenance of research software metadata. The following general requirements are recommended for end users, including researchers, software engineers, curated, and institution staff. So those are questions to look for. Is there metadata in the code? Is there a metadata record? So with extrinsic metadata, is that following license CC0 for the metadata? Because this is one of the recommendations that are in the guidelines, etc. Next, we have accessibility and preservation. So the importance of preservation, having a way, where do you preserve the code? One possibility, of course, is software heritage, but for research software, you might want other places too, like HAL for French researchers, or Zenodo. Don't know if you have institutional repository in Germany, but I imagine some institution might have that as well with Dataverse scholarly repository. So where is the archive artifacts are, and do we have access to them even beyond the code repository? Then the third aspect is reference and identification to ensure that research software project modules, version, and source code artifacts can be precisely identified and referenced. So if we look at the questions, can specific algorithm or code fragment be identified? Can a file or directory can be identified? And so on. Is the versioning scheme used? Is it possible to identify different levels of granularity in the content itself? Of course, this depends in the source code is accessible and available. Aspect 4 is about description and classification, and might be the most important of the aspects, and really describes the metadata record and what it should contain. Do we have a name, a description, a domain, a programming language, the date created, the date of first publication, some keywords, related links, and version? These are all properties that are available in CodeMeta, but also in Citation CFF. Is it possible to access articles describing the software? Also very important, the links between articles giving the context of the software. Next, we have attribution and credit. This is something that is not enough stressed in the FAIR for research software principles. Even in the FAIR principles, attribution and credit are not part of that, of FAIR, but it is important to get us this culture shift of recognizing software. So to ensure proper crediting and acknowledgement of software creators and authors and contributors, it is important to follow citation recommendation. So do we have a way to identify the authors and contributors, maybe with ORCIDs? So those are some of the recommendations about attribution and credit. Next, and I'm not going to read it, but you can have access to this slide later. For reuse, licensing, and legal aspect, the license is really crucial. This is part of FAIR, and this must be something that all institutions are obliging the researchers and research software engineers and developers to put in the code a license. This is very important for reuse, for legal compliance, and for that, it is truly important. This requires a full webinar on legal aspects. I don't know if you had one here, but there's a lot of different things to have in mind when choosing a license. It's not the first license that you come across, and normally institutions have very strict rules about licensing. And sometimes research software engineers or researchers are not aware of these rules. So make sure that you are aligned with the institution's policies. And finally, in the aspects, we have the re-execute with dependencies and execution environment, so that we can rebuild this software stack. Because if you released one piece of the software stack and we don't have the information about the full software stack, well, that would be very difficult to reuse in the terms of re-execute it and actually use the software. So there's a difference between using a software, so reuse in terms of use, and reuse like with the license questioning, where we reuse parts of the code. So the licensing is also important for that. And a few questions here: are the software dependencies described? Are the operating system and relevant environment requirements described? Are the build instruction available? Etc., etc. Making metadata actionable and discoverable is the real summary of all that is in this research software metadata guidelines, because we want to integrate data code and metadata to support the scientific understanding between domain experts, research software engineers, libraries, archivists, and curators, and also for infrastructure managers that are going to hold all of this information. They will have the publications, the data, the software. All of this needs to be understandable at the metadata level. So metadata enables different actions: discovery, citation, reproducibility, interoperability, and the most important one, recognition of research software. So last part of this webinar, supporting research. We have some new players in academia who are already the stakeholders that we meet, and we see the use cases that they can have with software. We have the researchers that they might want, but they should archive and reference software to find useful software, to get credit, to reproduce. We have laboratories and teams to track software contribution, produce reports, maintain web pages. And on the other side, we have research organizations that want to know the software assets for technology transfer, for impact metrics, for strategy. And somewhere in the middle, we have the curators. They want to verify and curate software metadata, provide documentation on how to better curate software and have better metadata, and monitor research teams' productions. And what about research software engineers? So yes, research software engineers have central role in all of these use cases to create and maintain research software, building the bridges between academia that is not enough integrated into software ecosystems, so having those bridges between language ecosystems and academia, support teams with technology. And I really like using this diagram by Neil Chu Hong. So you can see that it's written in black, but it's Neil Chu Hong's diagram, where the research software engineer is really at the central between software engineering and research, and has a pivotal role in academia. With that, a new role that we see coming up is the OSPO, the Open Source Program Officers within academia, that they have also a central role for research translation, for community, for research excellence and education. Also building bridges between academia and open source, supporting teams with technology. And research libraries have a pivotal role too, because the librarians are holders of the knowledge, and we are providing some support for the libraries because they want to see the long road ahead with availability, findability, traceability, and reproducibility. And for that, we are supporting the supporters with the archives and library interest group. So they are supporting this software heritage open infrastructure, and they get this tailored support and community of practice to participate in. And some of our members of this interest group are from different academic institutions and universities, not yet in Germany, but maybe soon. And I want to end this presentation with a few content slides. I know they are full of text and you will not read it all, but I want to share that we also released a metadata curation roadmap. And this is especially dedicated to support those supporters with a clear roadmap for the short, medium, and long term on how to make all of these tools and guidelines a reality. And I want to stress the 3 items from the 3 different slides. One, that adopting and adapting metadata guidelines is something that institutions can help with by require infrastructure to provide metadata capabilities that align with community-based guidelines, like the research software metadata guideline. This comes from the top. The institutions need to make the infrastructure have this accessible and available. On the medium-term recommendations, robust curation processes. There's a lot of manual things, manual creation of files. We want better curation processes so we can help both the curators, both the researchers, and of course the research software engineers to make it easy so that it is streamlined and automated. And here automation is part of that wherever possible, because metadata is necessary but not fun. People, well, I like metadata, that's my soft spot, but most people don't like to do metadata, right? So let's make it as automated as possible, even though we need humans in the loop to verify the metadata and make sure that there is that it is correct and not hallucinated by some AI. And finally, for the long-term recommendation, monitoring. Institutions should actively monitor the software production within their laboratories to ensure the quality, visibility, and impact of research outputs. Effective monitoring relies on the curation capabilities of the infrastructure in use, which must be equipped to track, manage, and preserve software throughout its life cycle. And this is the key to help the institutions see the value of making software a first-class output. So with that, research software engineer, OSPOs in academia can support the librarians and connect academia to the rest of the software world. And my call to action: software recognition requires a supported and coordinated effort. So here it's in EOS because I didn't change the slide, but it's everywhere in research software engineering communities, and well, we really need something coordinated, because we need to treat code not just as a tool, but as a core pillar of our intellectual heritage, and metadata is part of this journey. With that, I'm leaving you with one question, because you will ask me questions and we will stop the recording, but I do want to ask you about adoption through community engagement. What strategies do you believe are most effective for building bridges between communities and influencing adoption? So here, specifically adoption of metadata, metadata tools, metadata principles, metadata guidelines, and so forth. And with that, I really thank you for your attention. And I apologize if you have heard any kids sound in the background, but it's Wednesday here in France, so I have mine at home. Thank you very much, and I'm here for any question.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below, and see you next time.